Hi, I'm Teacher Thomas. Welcome to A-Level Mechanics. We're looking at the 2020 specimen paper for Mechanics, question 2. A constant resistance of magnitude 1,350 newtons acts on a car of mass 1,200 kilograms. A. The car is moving along a straight level road at a constant speed of 32 meters per second. Find in kilowatts the rate at which the engine of the car is working. B. The car travels at a constant speed down a hill inclined at an angle of theta degrees to the horizontal, where sine of theta equals 1/20, with the engine working at 31.5 kilowatts. Find the speed of the car. Starting with requirement A, I'm going to use the formula for power. P equals F, which is force, times V, which is velocity. The units are watts, newtons, and meters per second. Notice that our requirement is find in kilowatts. We're going to be solving in watts, so we'll convert to kilowatts after we find our answer in watts. Power equals force of 1,350 times velocity of 32. This value is 43,200 in watts. Thus, in kilowatts, we divide by 1,000 to get to 43.2 kilowatts. For part B, I'll also use the formula for power. Power equals force times velocity. Here I'm given the power, 31.5 kilowatts. In my equation, my units of measure is watts. So I'm going to use the value 31,500. Equals force times velocity. I don't know either of these values. I'm going to start with force. I want to equate my forces so that they offset to 0. The driving force is my unknown. I'll subtract resistance of 1,350. I'll now factor in gravity. Because I'm going downhill, I'm going to add gravity. Gravity will be 1,200 kilograms times 10 to get to newtons. The slope is going to affect the gravity. I'll multiply by the sine of the angle, which is given as 1/20. The sum of these three forces equals 0. Why 0? Because we're at constant velocity, thus there's no acceleration. Force equals mass times acceleration. If acceleration is 0, then force is 0. The combined forces, rather, are 0. We need the driving force to calculate velocity in our power equation. When we simplify, driving force equals 750, and now we can put 750 into our power equation. 31,500 equals 750 times velocity, and velocity solves to 42 meters per second. This completes the requirements for question 2.